Okay, this is Unit 4, Part 2, Day 2. So this is on differential equations. I'm going to go ahead and do just a few examples of each of these differential equations. So I'll just kind of work on this right-hand side. So there are a couple different things you need to remember for differential equations. So the first type is if you are working with a differential equation and there are only x's. So all these examples on this first page there's only x's on the right-hand side. The two, c and d, are different because you also have an initial condition along with them. So if that's the case, what you want to do is just integrate both sides with respect to x. So here you'd say that the integral of dy dx, and you're going to say I'm integrating that with respect to x, equals the integral of 3x squared with respect to x. So dx there as well. And what's going to happen here is those dx's are going to cancel out, you can say. And then so really what you're integrating is 1 dy equals the integration of 3x squared dx. So what's happening here is now you're integrating this one with respect to y. So when you integrate a constant, right, you just get the variable. The variable that you're going to end up with here, though, is a y because you're integrating with respect to y. So this ends up to be a y, and that's very common. So you get just a y equals, which is great because my solution to a differential equation is a function or set of functions. So it's going to be y equals, blah, blah, blah. And if it's a general solution like this one, meaning I don't have an initial condition, then I'm going to have a plus c in my answer. So when I go to integrate this side, you get, let's see, you're going to add 1 to the exponent, divide by that number, plus c. And those 3's are going to cancel, so my final answer is y equals x cubed plus c. Now technically some people say, well, how come when you integrated over here you didn't put a plus c? There actually is. It's going to be y plus c over here, but if you have a plus c on this side and a plus c on this side, well, you can just, combine those two constants together and call it c. So I realize that this c is different than that c, but it's still just some constant, so I'm allowed to do that. Now, if you're given an initial condition, you're going to kind of start it off the same way. You're still going to say, well, let's just say, well, the derivative, right, y prime is the same thing as dy dx. And we're still going to say that that equals this. And my strategy is going to be the same. I'm going to integrate both sides with respect to x. That's going to cancel, so you're going to be integrating dy. Well, when you integrate dy, it's really 1 dy, so when you integrate that, you get a y equals, add 1 to the exponent, divide by that number, add 1 to the exponent, divide by that number, and then I'm just going to put my plus c on the right-hand side. So you get to there. Now that's the general solution. Now what you need to do is apply your initial condition. So apply the initial condition. Well, this up here is my initial condition, so that tells me that x equals 0, y equals 1. So I'm going to do that. I just say y equals 1 and x equals 0. This one kind of works out nicely because 0 raised to a power is just 0. So this whole piece is 0, this whole piece is 0. So you get 1 equals 0 plus c. Now just be careful there. Make sure you're answering the question. If you want to solve the differential equation, you need to go back and say y equals x to the 5th over 5 plus x to the 4th over 4 plus 1. So basically you have to take this one and plug it back into that general solution to kind of get your answer there. So that's what you do if there is an initial condition. So notice in both of these examples that the right-hand side of the equal sign only had the variable of x. So to solve that, all you needed to do is basically integrate both sides, and if there was an initial condition, apply it. Now that's different than if you have to separate the variables. So you can tell right away just by looking at this example that you have an x and a y, okay? So right away that kind of says, that one's different, and you're going to have to use a technique called separating the variables. Now, you have a dy and a dx, so your goal here is to get it so that your y's are with your dy and your x variable stuff is with your dx, because then we're going to integrate both sides. So if I see fractions in an equal sign, I know I'm allowed to cross multiply. So I'm going to say y dy equals 2x dx. Okay, so I've got there. And now what I'm going to do is integrate both sides. So I integrate this side and integrate this side. Notice though, since I already have a dy and a dx, I'm integrating each side with respect to a different variable, and I'm doing that on purpose because now I'm going to integrate y with respect to y. So the integration of y, you're going to add 1 to the exponent, divide by that number, and technically there's a plus c there, right, equals. Now I'm going to add 1 to the exponent, divide by that number, and there's a plus c on this side, so I'm just going to call it all plus c. And obviously you can clean that up, those go away. But then I want to get y by itself. So to get y by itself, I'd have to multiply both sides by 2. So you get y squared equals, now I'm going to multiply that by 2 again, so I got 2x squared plus c. And again, I know that that is actually a 2c, but it's still just some constant. Okay, so I've got to there, and now to get y by itself, I take the square root. Keep in mind, when you take the square root of something, you need to indicate that you're taking plus and minus the square root. So right there is my final answer. So that technique is called separating the variables, and that finds the general solution. Notice in my general solution, I do have a plus c in my answer. All right, moving right along. Now I have x's and y's, so that tells me I need to separate the variables, and I have an initial condition. So I'm going to kind of do it the same way, but then I'm going to have to apply the initial condition. So I have dy dx, that's just y prime is dy dx, equals x squared square root of y, and you can write that to the 1/2 power if you feel like it. And then I'm going to cross multiply, I'll multiply both sides by dx first. I'll do it in 2 steps. So if you multiply both sides by dx, that goes away, and then you've got x squared square root of y dx. Now, I've got my x with my dx, but I need to get this to the other side. So you have to divide both sides by square root of y. Now I'm in a decent situation because now my y's are on the left and my x's and dx is on the right. To integrate this, you might want to write it one more time. So we know that this is to the 1/2 power. So if I bring it in the numerator, it's going to be y to the negative 1/2 dy equals x squared dx. And then I can integrate. So I integrate the left side with respect to y. I'm going to integrate the right side with respect to x because I got y variables and a dy on this side. So it's add 1 to the exponent, divide by that number. So dividing by 1/2 is the same as multiplying by 2. And again, I know that there's a plus c there, but I'm kind of leaving it off. I'm going to put it on the right-hand side. Add 1 to the exponent on the side, divide by that number, and don't forget your plus c. And so now I want to get y by itself, so I'm going to divide everything by 2. So I'm going to get y to the 1/2 equals, so if you divided this whole thing by 2, right, that's like multiplying by 1/2, right, dividing a fraction. So you're going to get x cubed over 6 plus, that part is still just going to be some other c. And then I'm just going to go over to the top here. So my final, so I've got y equals, to undo the 1/2 power, you could kind of think of it as square root of y, if that helps. To undo squared, or the 1/2 power, you would square both sides. So it's you're taking this side squaring it and taking this whole thing and squaring it. So you get y cubed over 6 plus c, the whole thing squared. Oops, sorry, a little off the page there. Okay, so there is my equation. And now, because I was given this initial condition, I'm going to apply it. So you apply your initial condition. This allows us to solve for c. So I apply x equals 3, y equals 4. Now, technically, any one of these steps over here, they're all, mathematically equivalent. But so plug into the one that looks the easiest. So I don't know, you could plug in there. It might be easy there. You're going to have to take the square root. So that wouldn't be hard either. It'll kind of have it separated, but I'll just do it there. So 4 equals, oh, sorry, my x was a 3. So I want this to be 3 cubed over 6 plus c, the whole thing squared. So, sorry, that's kind of in the way there. All right, so then you've got 4 equals, you've got 27 over 6 plus c, and let's see, to undo squared, you're going to square root both sides, so I'm going to do plus or minus the square root on this side to undo that squared. This one, you're going to have to branch it off, though, because you're going to have a positive 2 and a negative. So on one side, you're going to have negative 2 equals 27 over 6 plus c. And then on the other one, you're going to have positive 2 equals 27 over 6 plus c. Okay, so you kind of get two answers there. And, you know, you could change that into a fraction, or you can actually reduce that fraction, change it into a decimal. Either way, you are going to end up with c equals negative 6.5 and c equals negative 2.5. And then, again, to solve it, you want to go back up and plug them in. So you've got y equals x cubed over 6 plus negative 6.5 as one answer, and y equals x cubed over 6 minus 2.5 as your other. Oh, it's that whole thing squared though, isn't it? There we go. So that whole thing squared and this whole thing squared as your answer for that. Okay, and that's kind of the easy versions. The next examples I'm going to do are going to use our log properties, and they'll have to kind of rearrange e so that we can use it in a way that's more useful to us. Okay, so now we're going to do an example that is a little harder because it involves those properties of e. So again, we know that we're going to have to use the separation of variables technique because there are x's and y's together. And this time we also have an initial condition, so we're also going to have to solve not just for the general solution, but be able to apply that initial condition and figure out what c is. So I started by saying that y prime is dy dx, that part's fine. And when I see fractions in an equal sign, usually my gut reaction there is to cross multiply. So you may do that, but then you'd quickly realize that that is not actually going to separate your variables. So you'd almost have to think of it, I mean, you can do that and then rearrange, but what I would do first is I would probably rewrite it so that it was this and then this to the negative 2. Bringing that up, now I multiply both sides by dx, so then I get dy equals, so if you multiply by dx and then also divide by this at the same time, you're going to get those together, and then you're going to have x to the negative 2 dx. So in this step, I multiplied both sides by dx, and I also divided both sides by y plus 3 to get that over there. And so again, with a little clever rewriting, so you're going to have the, you know, this is the same thing as 1 over y plus 3 dy equals x to the negative 2 dx. Okay, so once you get to there, you're like, all right, I'm ready to integrate both sides. So integrate both sides, and then you're integrating 1 over, you know, y plus 3. So this would actually be a u substitution, but because the derivative of y plus 3 is just a 1, you kind of get away with, you don't really have to do the full u substitution. You know that that's going to end up to be ln of y plus 3. So, do I have room for that over there? Okay, so I'll just write it up here. Okay, so I'm going to say when you integrate 1 over the stuff, it's ln of the stuff, right? So we're going to have that. And again, I know that there's a plus c there. And then I'm also going to integrate this side. So I add 1 to the exponent, so that'll make that a negative 1. Divide by that number, it just puts a negative out front. And that is going to be a plus c over there. Okay, so once you get to there, you can raise both sides to the e, because you're trying to get y by itself. So the only way you're going to undo that, right, is to e both sides. So we do this. So ln and e kill each other, and technically that's absolute value, but when you do this step, it kind of drops that absolute value. So you're going to get y plus 3 equals. So then you've got kind of this mess here. You're like e to all this junk. Well, one of the properties of logs and exponents is that if you have two things of the same base, you can add the exponents. For example, if I had asked you previously, you know, just before this problem, I'm just going to do this off to the side. If I said, what's x cubed times x to the 4th, okay, you'd say, okay, like bases, you add the exponents. So this is the same thing as x to the 3 plus 4, aka x to the 7th. Okay, we're going to kind of use this property in reverse. So now I'm going to tell you that I want to rewrite this. See how it's like this, 3 plus 4? This is my 3 plus 4. So it's e to the 3 plus 4, you know, whatever plus whatever. I want to go backwards and write it as a product. So how am I going to do that? I'm going to write it as e to the negative x to the negative 1 times e to the c. And again, if you kind of apply this, you're like, okay, like bases, add the exponents, it would take me back. So I didn't do anything there that was mathematically incorrect. And I think it's sometimes easier to just kind of view it as something you already know. So we're going to kind of think of it like that. And then I got to get rid of this. And then, okay, so now what we can do is, because I have this e to the c, guys, e is a constant. So a constant raised to some other constant, right, is just some other constant. And you're going to do this very frequently in these types of problems. So just know that you can always rewrite this as just some c value. So there's going to be some c, and then it'll be times e. And again, that negative 1/2 power, if you'd prefer, you can think of it as negative 1 over x, right, if you want to think of it like that. So you've got that, and you want to get y by itself, so you could just subtract 3 from both sides. So I'm going to write it as this to the negative 1 over x, and then it is a minus 3 on the outside. So I've solved for y there, and now I'm going to apply my initial condition. So my initial condition is x is 2, y is 1. So I'm going to say, so apply IC for my initial condition. So I'm going to say 1 equals some constant, e to the negative 1 over 2, because my x value is 2, minus 3. And the whole reason we had to kind of go through this is, if you tried to apply your initial condition here, you'd get into a lot of trouble, because you could plug in you know, a y and an x value there, but you wouldn't ever be able to figure out that c. That's why we had to go through this process. Okay, so here I'm going to add 3 to both sides, so I get a 4 equals ce to the negative 1/2. Oh, well, darn it. Okay, I'll just write it in 2 steps. Okay, so having e to the negative 1/2 basically means that's in the wrong part of the fraction. So you can think of this as 1 over the square root of e. So you still have c, and then it's times 1 over the square root of e, because the negative 1/2 power means square root, but it's negative, so I got to put it in the denominator. So we've got that, and so once you have that, you can, you know, this is the same thing as 4 equals c over square root of e, and then let's just cross multiply, so you get c equals 4 square root e. Okay. So don't forget to go back. Your final answer should be y equals 4 square root e, okay, because that's my c value, times e to the negative 1 over x minus 3 is my final answer there. Okay, so quite a bit of work to get there, but we were able to get an answer. All right, so hopefully this next one's actually a little easier, a little less work, because I used up all my room anyways. So here you've got x's and y's on the right. So again, that separation of variable technique is going to be handy. I would start off by multiplying both sides by dx. So if you do that, you get dy equals 4x cubed y plus 20x cubed dx. Okay, so you've got that, and now you're like, well, how the heck am I going to, you know, move that around? Well, you'll notice here now you've got a GCF on this side. So, because you need to be able to separate them. So I'm going to pull out a 4x cubed, and I think that'll leave me with a y plus 5 dx on that side. Now that I have my y terms together, I can divide both sides by that. So I get dy over y plus 5 equals 4x cubed dx. And now I can do that integration technique. And again, if it helps you to write this side as 1 over y plus 5 dy equals 4x cubed dx, that might be a little bit easier for you. Okay, so I'm going to integrate both sides. I'm integrating this side with respect to y and the other side with respect to... Okay, so once you write it like that, you can integrate. And the integration of 1 over the stuff, as long as the derivative of that stuff is just a 1, you can just say it's going to be ln of y plus 5 equals the integration over here. You're going to have add 1 to the exponent, and then when you divide by 4, that 4 and that 4 kind of kill each other off. And then don't forget your plus c. So we've got that, and our goal here is to get y by itself. So to get this y by itself, we're going to have to e both sides. So you e both sides, and then you're going to use that same property. So the e and the ln are gone, so you've got y plus 5 equals, and you're going to use that same property. So if you need to write it out again, go ahead, times e to the c. And again, e to the c is just a constant, so some of you are going to start skipping that previous step there, and you're going to go right to just saying it's c e raised to the x to the 4th. Okay, so once you've got there, subtract 5 from both sides, so to get y by itself, and so you end up with ce raised to the x to the 4th, and then it'll be a minus 5 because I'm moving that to the other side. From there, you can apply your initial condition. So I'm going to apply my initial condition. So x equals 1 and y equals negative 3. So I'm going to say negative 3 equals c e, and since x is 1, it'll be 1 to the 4th, which is just 1, minus 5. Go ahead and add 5 to both sides, so you end up with a 2 equals, well, e to the first is just e, so it equals c times e. Divide both sides by e, so you get 2 divided by e equals c. And so then you're going to go ahead and plug that back in. So your final answer is y equals 2 over e, or you could write it as 2 times e to the negative 1, either or. And that'll be e x to the 4th minus 5. And that would be your final answer on that one. Okay, so go ahead and you can work through, excuse me, you can work through the rest of the homework. Hopefully that clears up some of those differential equations. Have a great day.